Nicolaus Copernicus, who was born as Nicola Copernic on February 19, 1473, in the region of Toron, located in Royal Prussia, and he is known as the father of modern astronomy. He was the youngest of four siblings in his family, while his father, Nicolas Copernicus Sr., had a successful career as a merchant. As a Polish astronomer and mathematician, Copernicus achieved a significant accomplishment by being the first European scientist to introduce revolutionary concept known as the heliocentric theory of the solar system, in which he suggests that the sun rather than the earth was the center of the universe. Lucas Watson wrote, being the uncle of Nicholas Copernicus, he was a very important person in church and very smart person. Became the respected bishop of Armenia in 1489 and took the responsibility of pastoring his nephew. He ensured that Nicholas received a quality education, support him financially for a comfortable livelihood, and also aided his advancement within the church. Copernicus went to a university in Poland called the University of Krakow in 1491 to 1496, when he was about 18 years old. He studied things like astronomy and astrology there, which are about stars and the planets. But he didn't finish his degree there. Then he went to another university in Italy called the University of Bologna in 1496 to 1501. He studied more things like law, medicine, and canon law, which is about church rules. While he was there, he did a professor who taught astronomy named Domenico Maria da Ferrara. The University of Bologna, where Novara recommended books like Epitome of Ptolemy's Almagest by Regiomontanus, which is the first printed edition of Almagest, and it presents state-of-the-art astronomy at that time when Copernicus was a young man. Then, disputations against divinatory astrology by Giovanni Picodelia Mirandola talks about why he disagreed with astrology. In May 1503, Copernicus finally received a doctorate like his uncle in canon law, but from an Italy university where he did not study, which is the University of Ferrara.
Administrative and medical rules. When Copernicus returned to Poland after his studies and was appointed as a church canon, his uncle Lucas Watson Road, who was a canon at Nuremberg Cathedral, arranged a sinecure for him. Copernicus also took on various medical needs to his fellow canon and his uncle, providing medical assistance when needed. This shows that Copernicus not only administrative duties but also played a role in medical field within the church. The church canon, he managed collecting rents from church-owned lands, secured military defenses, oversaw chapter finances, managed the bakery, brewery, and mills, and also he tended to the medical needs of fellow canon and his uncle.
Ancient planetary modeling traditions. In Aristotle's model of solar system, it is associated with the ancient Greek philosopher Aristotle. Planets move with uniform angular motion on fixed radii. It assumes that the planets move with uniform angular motion on fixed radii at a constant distance from their centers of motion. Planets carried on unchangeable, material, and invincible spheres. In this model, the planets are carried around the center of the universe in unchangeable, material, and invincible spheres at a fixed distances. Predictive model limitations, especially in explaining variations in planetary brightness. However, this model had limitations, especially in explaining variations in apparent brightness of the planets because of the distances from the center were always the same, so it was not a good predictive model. Ptolemaic model. It attributes to Claudius Ptolemy, introduced mechanisms to address the limitations of Aristotle's model. It proposed three mechanisms: eccentrics, that means uniformly revolving or off-center circles; epicycles, that is the little circles whose centers revolve uniformly on the circumference of larger circles are called deferents; then equants, which is an imaginary point located at a specific distance from the center. Equant concept allowed for a non-uniform motion, breaking with ancient astronomy assumption. The equant concept was introduced to account for variations in planetary motion, but broke with the assumption of uniform motion at a constant distance from the center. When viewed from Earth, a planet's motion would appear non-uniform when not observed from the equant. Challenge of wobbling spheres and potential collisions of spheres. Planets in the Ptolemaic model were imagined as spheres that would wobble or even collide if arranged one with another. Meragay solution. 13th century Persian astronomers devised a method using oscillating points to explain variations in planetary distances. They combined two uniformly revolving epicycles to generate an oscillating point, which explained variations in a planet's distance more effectively. This approach avoided the need for equants. This was used to model the motion of planets in a way that did not rely on the concept of an equant, which had been introduced by Claudius Ptolemy in his geocentric model of the solar system. Copernicus' response. Copernicus likely learned the American method through an intermediary source. Even though he did not read the American work, he likely learned the American trick through an intermediary source. Copernicus used the American insight to address the wobbling spheres in planetary models. He is concerned with the disagreement among astronomers about the order of the planet, particularly the positions of Venus and Mercury in relation to the Sun. He was disturbed by Pico's charge that astronomers could not agree on the actual order of the planets. The difficulty focused on the locations of Venus and Mercury.
The idea of heliocentrism. Heliocentrism developed during the last years of Watson Rhodes' life in early 16th century. It proposed that the planets in the solar system revolve around the sun. One piece that providing evidence of heliocentrism was the precession of the equinoxes. This is the gradual shift in the position of equinoxes along the ecliptic, which is the apparent path of the sun in the sky throughout the year. In contrast, the geocentric model was rejected, which suggested that the Earth was at the center of the universe. Although the heliocentrism model laid the foundation for the scientific revolution, it did have some shortcomings. For example, it failed to explain the observed phenomena accurately, such as the retrograde motion of annual orbit of the planets. Overall, the idea of heliocentrism model challenged the geocentric view of the universe and paved the way for the scientific revolution, leading to significant advancement in our understanding of astronomy and physics. The Commentariolus, or Little Commentary, written by Copernicus in 1514. A small manuscript that was circulated but never printed. Copernicus proposed that as a heliocentrism model of the solar system where the sun is the center of the Earth and the other planet revolves around it. This proposed that the sun is at the rest and the Earth is in motion, leading to a more organized planetary order, with the planets arranged in a specific order: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. This model provided a better explanation for the observed motions of the planets and helped resolve some of the issues posed by the geocentric model but introduced new challenges. Copernicus faced several challenges in his attempt to abandon the prevailing Aristotelian natural philosophy. One of the challenges Copernicus encountered was explaining falling objects. According to Aristotelian physics, objects fall to the earth because they are seeking their natural place, which is the center of the universe. Another challenge was integrating imperfect Earth into his cosmological system. Copernicus recognized that the Earth is not a perfect sphere and that it has rotational and axial movements. Additionally, Copernicus discovered the phenomenon of the precession of the equinoxes, which refers to the slow change of orientation of Earth's axis over time. However, the most significant challenge found by Copernicus was the incoherencies in his theory. Copernicus' heliocentric model still relied on circular orbits, epicycles, to explain the observed motions of the planet accurately.
The 7 postulates. So number 1, there is no one center in the universe. This postulate suggests that the universe doesn't have a single fixed center around. Number 2, the Earth's center is not the center of the universe. This postulate directly contradicts the geocentric belief that Earth is the central point of the universe. Number 3, the center of the universe is near the sun. These postulates introduces the idea that the sun is closer to the center of the universe than the Earth. Number 4, the distance from the Earth to the sun is imperceptible compared with the distance to the stars. Number 5, the rotation of the Earth accounts for the apparent daily rotation of the stars. This postulate explains that the daily motion of the star across the sky is the result of the Earth's rotation on its axis, which gives the appearance of the stars moving around on its own. Number 6 is the apparent annual cycle of movement of the sun is caused by Earth revolving around it. Copernicus suggests that the challenging position of the Sun in the sky over the course of the year is due to Earth's orbital motion around the Sun. So the last one is the apparent retrograde motion of the planets is caused by the motion of the Earth from which one observes. The retrograde motion of the planets, where they appear to move backward in the sky before resuming their normal path, is explained as an optical illusion caused by the Earth's orbital motion. The narratio prima, or the first narration, around 1540 to 1541. It is also known as the Libris Revolutionum Copernici Narration Prima. It is the abstract of Nicolaus Copernicus' heliocentric theory. The Narratio Prima is essentially an abstract or a summary of Nicolaus Copernicus' heliocentric theory, which would later be fully elaborated in his major work. It was written by George Joachim Ridicus in 1540. The Narratio Prima serves as an introduction or precursor to Copernicus' major work, which was published in 1542. This document represents one of the first printed publications of Copernicus' heliocentric theory. It is joint production of Copernicus and Ridicus. While Ridicus is the author of the Narratio Prima, it's important to note that this document was produced in collaboration with Copernicus. It provided what was missing from the Commentariolus. Narratio Prima is seen as a complementary work to Copernicus' earlier document, the Commentariolus Revolutionibus Coelestium, or On the Revolutions of the Heavenly Spheres of Nicolaus Copernicus. It is a seminal work of Copernicus. The Revolutionibus Orbium Coelestium is the most famous work by Nicolaus Copernicus. It is a seminal contribution to the field of astronomy and cosmology. It laid the foundation for modern astronomy. This work fundamentally changed the way we view the cosmos. It introduced the heliocentric model, in which the sun is at the center of the solar system. It used detailed mathematical calculations. Copernicus didn't really propose a new model. It met some resistance and controversy. The revolutionibus faced resistance and controversy, particularly within the scientific and religious communities. It challenged the geocentric model by Ptolemy. Claudius Ptolemy's geocentric model had dominated astronomy for over a millennium. Copernicus' work challenged this entrenched view by presenting a compelling alternative. It was published in 1543, shortly before his death. This marked the culmination of many years of work and significant achievements of his lifetime. It is one of the most important scientific works in history. The Revolutionibus Orbium Coelestium is widely recognized as one of the most significant and influential scientific works ever published.
Before the publication of Copernicus' De Revolutionibus Orbium Coelestium, the groundbreaking work underwent significant alterations and controversies. Nagsimula ang lahat nang pumunta si Ridicus, isang professor sa Wittenberg sa Nuremberg, Germany, para may publish ang manuscript ni Copernicus. Pinili ni Ridicus si Johann Petraius na isang renowned printer upang may lathala ang nasabing manuscript. Ngunit kinakailangang umalis ni Ridicus at naiwan ang manuscript kay Andreas Ostrander na isang theologian upang may lathala ang manuscript ni Copernicus. At dahil dito, may ginawang pagbabago si Ostrander. Naglagay siya ng unsigned letter to the reader pagkatapos ng title page na nagsasuggest na ang mga hypothesis ng libro ay hindi totoo at ang astronomy ay hindi kayang magpaliwanag ng celestial phenomena. Nasira ang tiwala ni Petraius at Ridicus kay Ostrander at minarkahan ni Ridicus ng pulang letrang X ang mga copies na pinadala sa kanya. At sa dala ng galit ni Tideman Giza na isang Roman Catholic bishop, nagdemand siya na payagang mag-reprint si Petraius nang walang pagbabago ni Ostrander. Ngunit tinanggihan ito ng City Council. Ang ginawa ni Ostrander ay nanatiling sekreto sa publiko, not until Johannes Kepler revealed it in his work Astronomia Nova in 1609. Additionally, the title of Copernicus' book was altered from the original manuscripts on the revolutions of the orbs of the world to 6 books concerning the revolutions of the heavenly orbs. This change appeared to downplay the book's claim to describe the real universe. Despite the publication struggles and the alterations made by Ostrander, the book managed to be seen as a new method of calculation rather than a work of natural philosophy, which may have contributed to its initial positive reception. The full transformation of Copernicus' predictive mechanisms into a new philosophy about the fundamental structure of the universe would have to wait until Kepler's time. What did Nicolaus Copernicus discover? Earth and planets revolve around the sun, or the heliocentric theory. Major flaws in the work include his concept of the sun as the center of the whole universe, not just the solar system, and his failure to grasp the reality of elliptical orbits, which forced him to incorporate numerous epicycles into his system, as did Ptolemy. The Julian calendar then in use had become so inaccurate that it fell out of time with the seasons. Copernicus submitted a statement to a 1512-16 council convent to address the problem, in which he called for more accurate observations. A new Gregorian calendar with leap years was introduced under Pope Gregory XIII in 1582 and still in use today. All about Nicolaus Copernicus. Some historians believe that Copernicus' name derives from Koperniki, a village in Poland named after a tradesman who mined and sold copper. He was a polyglot. Growing up, Copernicus likely knew both Polish and German. Nicolaus Copernicus attended 4 universities before obtaining his degree. Copernicus suffered a stroke and paralysis in 1542 and passed away at the age of 70 on May 24, 1543.